Hello everyone, welcome back to our channel. We were discussing complex numbers and quadratic equations for class 11th Maths NCERT. We already discussed how do we add, subtract and multiply complex numbers. Now let's see division. So if you have two complex numbers, say z1 is equals to a1 plus ib1 and z2 is equals to e2 plus ib2, then your z1 upon z2 can be written as z1 multiplied by 1 upon z2. So if we know the value of 1 upon z2, we can place it here and then multiply by z1 to get the respective division. Let's calculate 1 upon z2 separately. z2 is equals to e2 plus ib2. 1 upon z2 is equals to 1 upon e2 plus ib2. We will rationalize over here. That means multiplying by e2 minus ib2, negative of the second term, upon e2 minus ib2. If you multiply divide by the same term, your result, it doesn't change. This is equals to e2 minus ib2 in numerator upon first term plus second term and first term minus second term. So here you can apply the formula for x plus b into x minus b, whose value is equals to x square minus y square. Your formula is x plus y into x minus y is equals to x square minus y square. So your equation denominator becomes a2 square minus I square into b square into b2 square. Now we know that I square is equals to minus 1. So this gets transformed into 1 upon z2 is equals to a2 minus ib2 upon a2 square minus of minus 1 into b2 square. This is equals to a2 minus ib2 upon a2 square plus b2 square. Since it's a complex number, let us represent it by z2 inverse. This is another notation for the same. Since it's a complex number, it can be represented as real part and imaginary part. So, placing this value here, your z1 is equals to a1 plus ib1 and your z2 is equals to a2 minus ib2 upon a2 square plus b2 square. This will be equals to a1 plus ib1 multiplied by a2 plus ib2 minus ib2 in the numerator whole upon a2 square plus b2 square. Now multiplying numerator, we get 4 terms, a1 a2 plus ib1 a2 minus ib2 a1 minus plus minus I into I is I square. So I square value is minus 1. Let's write it in the next step. I square into b1 b2. Now minus I square will be equals to minus of minus 1, which is equals to 1. So instead of minus I square, we will place 1 in the next step. So you get a1 a2. This is 1. This is plus b1 b2, which is a real part. We are merging, we are separating real part and imaginary part. Plus I common in second and third terms, we're left with b1 a2 minus b2 a1. The denominator can be split into two parts. Once it can be written, here you'll also have the denominator. So denominator is a2 square plus b2 square. Here also you have a denominator a2 square plus b2 square, but you can split it into two parts. So real part divided by a2 square plus b2 square plus I times imaginary part, this divided by a2 square plus b2 square. So this is the value for z1 upon z2. Here you have obtained two values, one for 1 upon z2, another for z1 upon z2. Let's box these. This is the first formula, and this is the second formula. Next, the addition and multiplication of complex numbers has certain properties. So addition and multiplication. The first property is closure property. Now closure property states that if you add two values of one type, you should get the result in the same type. That means if you're adding two complex numbers, a complex number plus another complex number should attain you a complex number. Similarly, a complex number multiplied by a complex number should give you a complex number. Z1 plus Z2 is equals to Z3. All Z1, Z2, Z3 are complex numbers. Z1 into Z2 is equals to Z3. All Z1, Z2, Z3 are complex numbers. This is closure property. Or closure law. Next, commutative property. Commutative property states that if Z1 is equal Z1 plus Z2, Z1 and Z2 are added, then you can add them in any order. This is commutative. If you multiply Z1 with Z2, you should get the same value if you multiply Z2 with Z1. So both addition and multiplication are commutative in nature. Next, associative. Associative property states that if you have Z1, Z2 and Z3, then you can multiply any two with third to get the final result. In multiplication as well, Z1 into Z2 into Z3 is equals to Z1 into Z3 into Z2 is equals to Z2 Z3 into Z1. Next property is existence of identity. So, identity. Additive identity is 0 and multiplicative identity is 1. This identity, additive identity, is also called as zero complex number. Next, we have additive inverse or multiplicative inverse. So, inverse. Inverse is that value. Here you'll have minus z, which when added or in multiplication multiplied with additive identity will give you, which when added, additive inverse, which when added with itself, scratch that, sorry, it's better to write. So your additive identity, which is minus z plus, because you're going with addition, the original complex number will give you additive identity. Here, the multiplicative inverse, multiplication with the original complex number, will give you multiplication identity. This is how additive inverse, additive identity are related, and multiplicative inverse related to multiplicative identity. Next, distributive property. You have z1 plus z2 and you're multiplying the whole thing with z3. Then it can be written as z1 z3 plus z2 z3. Similarly, z1 into z1 into z2 plus z3 will give you z1 plus z3 into z2 plus z3. In a complex number, z is equals to a plus ib. We know that a and b are real values. Real value, real part. This real part is a. Real part of z is equals to a. A real part of z, it can be shortened as capital R small e, bracket represents of, in bracket you have to write the name of the complex number, is equals to a. Similarly, imaginary part of z is equals to b. So imaginary is written by capital I small m of bracket z is equals to b. So if you find this in your question, understand, if you find a real part of z, understand that they're talking about a, and if you find im of z somewhere, understand that they're talking about b. If you consider two real numbers, z1 and z2, then z1 and z2 can be said to be equal only if their real part are equal. Real of z1 is equals to real of z2, and imaginary of z1 is equals to imaginary of z2. The vice versa is also true. So if real part of z1 is equals to real part of z2 and imaginary part of z1 is equals to imaginary part of z2, then it implies z1 is equals to z2. If you consider z1 is equals to a1 plus ib1 and z2 is equals to a2 plus ib2, then this condition states that z1 is equals to z2 only when bubble implies a1 is equals to a2 and b1 is equals to b2. In a complex number, z is equals to a plus ib if a is equals to 0. That is, the real part is equals to 0. Then your z is said to be purely imaginary. Number whose value will be equal to I into b. Similarly, if your imaginary part is 0, that is a is equals to 0, then imaginary part is equals to 0, which means your z value is equals to purely real number, whose value will be equal to a. This means that any real value can be represented in complex form. Let's consider -1. So -1 can be written as in complex form as -1 plus I into 0, because this is ultimately -1. So you can take b part as 0 for all real values, or all real numbers have their imaginary part values as 0. We'll continue further in this chapter in the next class. Thank you.